Hello everyone, this is Aman Sahu. In this video we will discuss about how to perform pushover analysis on our structure. Basically, pushover analysis is the non-linear static analysis, or you can say if you go to the non-linear performance of the structure, then the first step to do pushover analysis on our structure. So in this analysis we just giving the monotonically load on the structure in lateral direction, and because of that forces, structure get deflect, and at a certain predefined point we will see what is the hinges or how much deformation is happen. So I am assuming that you are know all about all theory about pushover analysis. So in this video we will see only software part. So I am starting to make one structure, and after that when our design is completed, then after we will go to the pushover analysis part. So first you can see our unit is metric SI India, steel section database according to India, and steel design code is IS 800, and concrete design code is IS 456. So let's start. Structure object is a grid only. So number of grid is 3 in x direction and 5 in y direction, and spacing of the grid in x direction is 5 meter, and in y direction it is 3 meter. Number of story is 5, and typical story height is 3.3, and bottom story height is also 3.3. Now you can see our grid is defined. Now I have to define the materials. So define material property. You can see there is already by default some materials. So I need M25 grade concrete. So I am adding new materials. India concrete, material type is concrete, standard India, and grade is M25. Then okay. So now you can see I defined M25 concrete. So this is by default all material data according to our code. Now property non-linear material data. So it is very important, because for non-linear performance we have to do this. We have to know this all parameter which is given here in this display. So you can see this is our first is material name is M25, material type is concrete isotopic. Hysteresis type is very important. Actually we can I will show you this, I will tell you this all hysteresis type. So but generally we will take concrete, or you can go to the Takeda also. So just by default whatever given here, I am not changing anything here. Now you can modify the hysteresis also, but just I am assuming that so this is acceptance criteria. Acceptance criteria means there is a performance point on our structure, IO level, LS level, and CP level. This is showing that how much deformation or how much strain in our structure is accepted. For IO level, how much strain is accepted? It is 0.01, and IO means immediate occupancy, LS means life safety level, and CP means collapse prevention level. Means after this level I am not allowing any strain on our structure. So after this I am assuming that our structure is completely collapsed, so I have to make our strain within this CP level. So it is very important. Now according to your strain, means in the tension side this is the strain, and compression side this is the strain. So you can see according to that strain our stress strain curve is this. You can see this is strain side, x direction strain. So this is compression and this is tension on the concrete. So you can see if this is our IO level, is green one is IO level, and LS level is this blue one. If suppose I am decreasing the strain value, by 10 times, then you can see I am making the structure more safe. Means 10 times it is safe, because our performance strain is very less. So we have to think, we have, according to our structure purpose, we will decide the performance point. So just by default whatever given here, I am not changing anything, because just to showing you what is this criteria, what is this levels, that's why I am telling you these things. And material damping, this is damping property for concrete, it is 5%, means 0.05. And this is time depending property, so I am ignoring the time depending property. Now you can see our M25 grade concrete is defined. Now I need reinforcement, so add new material, India, reinforcement for rebars, India, H/SD 500. So same thing as concrete, this is material property, this is according to our stress strain curve, this is the property of the rebar. And non-linear data, you can see stress type is kinematics for concrete, for rebars, and this is our performance point, and this is our stress strain curve. You can see after this strain, suppose it is 60 into 10 to the power minus 3, if my strain is more than this, means nearly, if you assume that it is nearly 60 into 10 to the power minus 3 strain is occurring in our structure, then our structure will collapse. So we have to think, we have to make strain is less than this CP level, you can see. And material damping for steel, it is nearly 0.3%, but we are ignoring the reinforcement damping. So now our materials are defined.